So, if I understand correctly, you and your lab are trying to map all the proteins of the virus.
Yes, there are 29 genes or proteins associated with the coronavirus.
Yeah.
And there are over 20,000 human genes and proteins in our cells.
Yeah.
So the virus cannot live by itself. It needs our cells, our genes, our proteins in order to live and to replicate. So what we have done is isolated each one of the coronaviral genes or proteins, put a tag on them. Essentially, it's a hook. And you put them into human cells, and they use the hook to pull them out of those cells. And then you see which human proteins each viral protein is talking to. And the assumption is whoever the human proteins are that they're talking to or directly touching, those are human proteins they're going to need in order to replicate and infect in our cells. And during the course of this study, we identified 332 human proteins that we think the virus potentially needs in order to infect our cells. So obviously there's no treatment right now for the virus, and what we did here was look at the 332 proteins in great detail and identified drugs or compounds that we think would bind to and inhibit the human proteins. And this is an attempt, obviously, for drug repurposing. These are drugs or compounds that are being used for other diseases, since obviously no one knew about coronavirus until recently. They're mostly anti-cancer drugs. And in total, we identified 69, 27 of which are FDA-approved drugs, and the rest are in clinical or preclinical trials right now. So we think that these drugs and compounds could hold promise for fighting off infection.
I see. You say mostly anti-cancer drugs.
Yes.
Because here in Italy, the drugs that are being tested right now are a couple of antivirals like remdesivir, and then a combination of lovinapir and another antiviral, and then there is another anti-inflammatory, which is tocilizumab, and then is chloroquine, a special form of chloroquine, and then there is drug which is coming from Japan, which is called it's Evigan. It's the commercial name.
Yes. So a few comments about these drugs.
Yes, please.
And I do hope they work. So chloroquine obviously has gotten a lot of press recently. And chloroquine is an anti-malarial drug. And on the surface, it seems, well, how would this make sense? How would an anti-malarial drug ultimately serve as an antiviral? However, if the chloroquine is actually inhibiting a human protein that the virus needs in order to optimally infect our cells, this could have a positive effect. And indeed, one of the 27 FDA-approved drugs that we identified is actually one of them is chloroquine. We had predicted that chloroquine is actually binding to a human protein that we think the virus may need. So this could be an indirect phenomenon. So actually I have maybe a little bit more hope that chloroquine could be used. However, that being said, as Tony Fauci says at the National Institute of Health, more tests are needed. We need more data. We need trials. And people should not be encouraged just to be taking drugs without all the information. Now, on the other side, you had brought up some antivirals. And these are viruses, drugs that are being used in the past to treat other viruses. So one of them is an anti-Ebola drug. And hopefully there's some effect there. However, one problem with antivirals, where you have a drug that targets the virus, is that the virus mutates and you get resistance. You can get resistance very quickly. And if you look back at HIV, what you really needed to do is have this cocktail of 3 drugs to really overcome this problem of resistance. Now, our approach is different. Okay, so here we're looking at the host. We're looking at the human proteins that the virus needs in order to optimally infect our cells. So we don't mutate as fast as viruses, right? Now, the problem is side effects and toxicity if you target a human protein with the drug. drug, obviously you could have side effects and toxic events. However, the fact that we're initially looking at FDA-approved drugs, this toxicity issue would be less of a concern.
Yeah.
Okay. And the other thing to say is that we've worked on a number of different viruses, many different viruses, and we find similar human proteins that each of the different viruses need. So if we can find a treatment for a human protein for COVID-19, it could be effective for COVID-22 or other viruses. So the push we're doing here is host-directed, looking at human proteins, pan-pathogenic, that is to say it could have an effect on many different viruses, and then number 3, looking at already approved drugs. Because to me, this is the shortest path to coming up with a treatment that could be effective.
I see. This is the novelty, yeah. Host-centered, pan-pathogenic, and pre-approved, pre-FDA approved.
Exactly.
It makes a lot of sense.
Well, it does. Thank you very much.
Yeah, it was a joke, of course. According to you, time-wise, how much time will you need to narrowing the number of human proteins that are the perfect companion for the virus?
Well, it's a good question. I mean, one thing I'd like to say is it's the research is moving, I would argue, at an unprecedented speed, and that's because of collaborations. You know, science is often very siloed, and very individualistic, where the individual gets rewarded for a discovery, not a group of people. However, in this case, I'd like to say at our institute, 22 different laboratories have come together at the Quantitative Biosciences Institute at UCSF. Essentially involving hundreds of different scientists, and this has been unprecedented. So we've broken down silos there. We've also broken down silos across different institutions around the world. We're now collaborating very tightly with a group in New York at Mount Sinai Hospital and at the Pasteur Institute in Paris. They have the virus growing in the lab. We don't. So the predictions we're making, they're now testing. And we're preliminary results are now coming in. And then the other thing to say is we're breaking down silos is between academia and big pharmaceutical companies. So we're working closely with Roche Pharmaceuticals. To me, this is a silver lining, I would say, in all of this, is that scientists are now truly working together in an unprecedented way. And I hope that this will speed up things. It definitely is speeding up things in a way I've never seen before. And I hope that this infrastructure stays in place so we can work together on the next pandemic or the next disease. Now, back to your initial question, how long will this take? It's a good question. You talk about a vaccine. Well, a vaccine could take a year or not at all. I mean, there's still not a vaccine for HIV, although that's been talked about for decades. Normally, a drug to get into a person, it takes many years from start to finish. But if there is some promise with some of these pre-approved drugs, and in the laboratory, if we get some promising preliminary data, I hope that this can be transitioned quickly to human studies. And who knows? I mean, maybe in a few months we could have something that could be useful. But that may be optimistic. But I mean, if you don't try, you're not going to find it.
Do you know anything about, because in Italy, strangely enough, that a Japanese drug, that avviene, which is an antiviral, made a lot of sensation because of a video which became viral from a Italian pharmacist in Japan who said, "Look at this guy. I mean, in Japan there's no problem because they use this drug." And then, I mean, it quickly became a sensation. But what do you know about it?
Well, there needs to be more data collected. I know with the anti-Ebola drug, there's clinical trials ongoing right now, including one here in San Francisco. But I would encourage people to actually listen to the medical professionals. First and foremost. I think Tony Fauci here in the United States has been a great role model. And I would not just listen to random people on the internet. That's the main message, because you could find everything on the internet. So please try to get your information from reputable sources.
Okay. A very last quick thing. According to you, how prepared is the US to tackle these pandemics?
Well, it seems at this point right now not prepared enough. And one of the downfalls here, it seems right now, is the lack of testing. You look at places like South Korea, and I think Japan too.
Yeah.
They quickly implemented mass testing, and that is so important in order to contain the spread of the virus. So at present time, we just don't know how prevalent it is around the country, and it's probably 10 times or more prevalent than we realize. And we were not prepared with respect to testing, so we're learning a lot of lessons here. But again, a silver lining here, in my opinion, in the research community, in the scientific community, we're learning how to work together in an unprecedented way. And as I said before, I think we're building a new paradigm of how to do science in a truly collaborative way as we break down these silos. And I hope that this infrastructure remains in place forever. And so we'd be much more prepared for, as I said, the next pandemic or any other disease that we would like to target.
I see. Anyway, if I get it correctly, you want to really stress the fact that your approach, I mean, it's very innovative because it's host-centered and targets the human proteins, which are the transmitter in a way of the virus. Okay.
Yes, exactly. And we've been exploring that approach for many years, but now it's really come to the forefront for obvious reasons.
Because that was the mapping that you were doing also in the last few years.
Yeah, we looked at HIV, we've looked at Ebola, we've looked at West Nile virus and Zika and dengue and bacterial species such as tuberculosis. So we've had a lot of experience doing this, although, mind you, those projects usually take a couple of years, and what usually takes a couple of years, we did in several weeks, which was, again, another unprecedented thing, I would argue, a testament to the collaborations that have been going on here in San Francisco and around the world.